What's up, welcome to Unit 2, Lesson 0, where we're going to be talking about the real number system. So here we go, along with the graphic organizer on your note sheet. Let's begin. So the real number system composed of rational numbers and irrational numbers. Go ahead and pause the video and write in everything on your organizer that you see right now. Exactly where I put it. Okay, so you should have written down, I've written down so far. All right, here we go. So all real numbers are rational or irrational. Let's distinguish between the difference between rational and irrational. Here we go. So our rational numbers are a number. So they're a number that can be written as a fraction of two integers. So that's a rational basic definition. So some examples of that could be 2 to 3, which is equal to 0.6 repeating. Another example could be -1/5, which is -0.2 as a decimal. Any perfect square roots. So perfect square roots. If I write too fast, just pause the video. So the square root of 25 is equal to 5. The square root of 49 is equal to 7, and so on. Any perfect square. Okay? Also, if you have like 826 divided by 1, well, that's equal to 826, so that works. -3 divided by 2, that also works. So any fraction that can be represented as a fraction of two integers, any number. Now let's talk about integers. Integer, no fractions or decimals. So if your simplified answer becomes an integer, that's fine. But if it stays as a fraction or decimal, you can use that as an integer. So for example, -3, -2, -1, 0, 1, 2, 3, and so on. Okay? Now our whole numbers are 0, 1, 2, 3, 4, 5, and so on. No negatives for our whole numbers and no decimals. Okay, that's a 1. Now our natural numbers, our counting numbers, are counting numbers. So exactly learn to count when you're a kid. Our counting numbers are 1, 2, 3, 4, 5, and so on. So all of our positive whole numbers that are not 0. So now let's talk about irrational numbers. Irrational numbers. Irrational numbers are numbers that are not rational. Kind of makes sense, right? They're the opposite of rational. They're irrational. Oops, sorry, misspelled that. That are not rational. So an example of that is square root of 11. The square root of 11, if you put that in your calculator, you get 3.3166624 ... It goes on forever. Square root of 2. Square root of 2 is equal to 1.4142135. It goes on forever. Square root of 5, square root of 6, square root of 11, square root of 12. All of these are examples. So they're non-perfect square roots. Those will all result in irrational numbers. Also pi. Pi is also a perfect example. 3.14159.265, and it goes on forever. Those are all examples of irrational numbers. Okay? But both rational and irrational are the part of the real number system. Okay? Alrighty. Now flip over your page or look at your student handout note page. We're going to go through these examples here. So Mrs. Mayo wrote some examples of rational numbers and irrational numbers on the right side. I want you to write down any observations or predictions you might have about rational and irrational. Like, what about rational numbers make them rational? What about irrational? So pause the video, write the things you notice about the examples that Mrs. Mayo wrote. Okay, welcome back. So they're numbers, so they're whole numbers and decimals, so terminating decimals, decimals that end, and fractions. That's what I noticed. Hopefully you noticed similar things. Rational, irrational. I see pi. I see never-ending decimals. That's what I see for irrational. Okay. So definition of rational numbers. Here we go. Rational numbers can be written as a fraction ratio. They're also terminating and repeating decimals. So terminating and repeating decimals, and square roots of perfect squares. Those are rational numbers. Now, irrational numbers cannot be written as a fraction or ratio. They're non-terminating, which they do not end. Non-terminating decimals and non-repeat. Okay, perfect squares of non-perfect squares. All right, let's do a few of these as an example. Negative 12, we know the rational integer. Negative 12 is an integer, so that is a rational number. Pi, irrational, because pi is equal to 3.14159, yada, yada, right? So it's non-terminating. Non-terminating decimal. Okay, 0.6, that is rational because it's an endpoint. It is a terminating decimal. 7/8, rational because it is a fraction. Fractions are rational. Go ahead and pause the video and see if you can get the next 4 or 5 of these without my help. I'm just going to get answers. All right, welcome back. You should have gotten irrational. You should have gotten rational, irrational, rational, and then rational. 121 is a perfect square. Perfect square. This is a terminating decimal. Square root of 20 is irrational because it is a non-perfect square inside the square root. And then 0.33 is rational. It is a repeating decimal. And then the last one, it is a non-terminating and non-repeating. Okay. All right, guys, we are now to this backside, okay? So you should be able to be fine with using this note sheet in your organizer to finish the rest of the must-dos, the should-dos, and, of course, pattern mastery check for 2.0. All right, guys, go ahead and continue with the units.